All right, now we're ready to go ahead and start graphing these. So let's go ahead and go over the guidelines for analyzing and graphing rational functions. So first, we know what a rational function looks like. It's just a fancy way of saying a fraction. And so what we're going to do, step one, is find the y-intercepts, if there are any, by evaluating f of 0, and that's by definition. You let x equal 0 to find your y-intercepts, if there are any. And then step two, find your x-intercepts, if there are any. And what we do there is we set the numerator equal to 0 and solve. And that's something we haven't covered yet, but that will be important moving forward for the next lesson. You can still graph these without finding the x-intercepts, but our next lesson, that's going to be important that we find that. Then we're going to find any vertical asymptotes by solving the equation of the denominator, set equal to 0. And then step four, find the horizontal asymptotes. If there are any, we will have them, okay, using the rule for determining the horizontal asymptotes of rational functions. So that's where we look at the exponents, and if they're the same, then you take the ratio of the coefficients, and if the numerator is smaller than the denominator power, then it automatically is going to equal, it's going to be y equals 0. Then part 5, we're going to plot some points beyond each vertical asymptote. So wherever you see a vertical asymptote, you want to make sure you plot points beyond them. If there are multiple vertical asymptotes, then you need to plot at least 3 points in between them, and we'll see that when that comes up. And then part 6, the main thing is you want to kind of have a smooth curve to complete the graph between and beyond the vertical asymptotes. So just try to make sure everything's nice and clean and smooth. So let's go ahead and get started. So for x-intercepts, the definition was to set the numerator equal to 0, and there's really no way to do that because the numerator doesn't have a variable, so there isn't going to be an x-intercept in this one. Y-intercept, by definition, we're going to let x equal 0, so that's what we'll do here. F of 0 equals 3 over x plus 3. Oops, go ahead and plug in the 0 there. And so we end up with 3 over 3, which equals 1. So we figured out the y-intercept is at 0, 1. So I'll go ahead and plot that now. And then the vertical asymptotes, in this case, we'll only have one. You set the denominator equal to 0. So x plus 3 equals 0. And then when we solve that, x equals negative 3. That's our vertical asymptote. We'll go ahead and plot that. So that's going to be right here. That's my vertical asymptote. And then horizontal asymptote, we can see that when you compare the variables, there is no variable on top, so it has an understood power of 0. And so the power on top is smaller than the power on bottom, so it defaults to y equals 0, which will be right here. Okay. And so I already have 1 point beyond to the right of my vertical asymptote at x equals negative 3. I already have one here. You can find some more if you want, but really you only need 1 point here because it's going to get boxed in by the asymptotes. That's what they're there for. They're there for guidance. And so it doesn't have to be perfect. You want to make sure you're in the right place, but basically I'm just going to kind of draw this with a curve and come down through that point, the y-intercept, and you just go along the asymptotes. Those are just guardrails, and so that's perfect. That's fine right there. Now I do need to figure out a point over here because it is possible that it might be up here or it might be down below right here. Typically they're diagonal of each other, but not always. So to be sure, I need to go ahead and plug in a point like, I don't know, -5 or -4, whatever you want to pick. I'll go ahead and pick -5. So let's go ahead and try f of -5. So that'll give us 3 over -5 plus 3, which then gives us 3 over -2, which is the same thing as -1.5. Now when you're doing your homework, just leave it as a fraction. But sometimes I like to go ahead and put it as a decimal just because we have a little better understanding of those. But on the homework, they're going to ask you to go ahead and leave it as a fraction. So just be aware of that. And then I'll go ahead and draw the graph. I'm going to change that to a red point. There we go. Now I'll go ahead and draw the graph and use my guardrails here and here. And there we go. And when you're doing your homework, the graphs are going to be multiple choice. So that should help you out a little bit there. Now, I always have students email me about the plot the points part, because on the homework, what they're going to do is they're going to ask you to find a lot of points. And really, it's just algebra. Okay, so don't get too hung up on that. So they might ask you for like f of 3, f of negative 6, stuff like that. So I'll go ahead and find those real quick. So they're going to ask you probably for 5 or 6 of these. Don't get hung up on it. Just be careful. Make sure you're simplifying and all that good stuff. So for example, f of 3, you get 3 over 3 plus 3, which is 3 over 6, which is great. But you need to go ahead and simplify that to 1/2. So you'll have questions like that. Now let's try negative 6. So let's see, 3 over negative 6 plus 3. So you get 3 over negative 3, which is a negative 1. Okay? You can see that point right there. So it's fairly accurate on our graph that I had right there. So like I said, I always get questions about this. Just on your homework, they're going to give you a bunch of values. All you're doing is plugging them in. Just make sure you're taking the time to simplify and be careful. Okay, here's our next one. So this time, let's see, the x-intercept, you're going to set the denominator equal to 0. And this time we do have 1 here because we have a variable in the top. So negative 2x plus 3, we'll set that equal to 0 and solve. So we'll subtract by 3 on both sides. And then we will go ahead and divide by negative 2. And we get x equals, now this is going to turn positive. It's going to be positive 3 over 2. And once again, let's just leave that as a fraction. As a decimal, it's 1.5. But go ahead and leave that as 3 over 2, comma 0. So that point is about right here. Okay, so I got 1 point already. And then let's see, let's go ahead and figure out the y-intercept. So for that, you plug in 0 for x. So f of 0. So we're going to have negative 2 times 0 plus 3 over 0 plus 1. And so let's see, we're going to end up getting, let's see, 3, it looks like just 3 over 1, which is then just 3, right? So that would go away, and you're left with 3 on top, and 0 plus 1 is 1. So let's see. Our y-intercept's at 0, 3, right there. Okay. Vertical asymptote, set the denominator equal to 0 and solve, and that's how we'll figure that out. So x equals negative 1. That's my vertical asymptote. So I'll go ahead and put that on here. Okay. And my horizontal asymptote, if you notice, we do have the same variable powers on top and bottom. The highest on top and the highest on bottom are the same. So you take the ratio of the coefficients. So negative 2 over 1, or we'll just reduce that to y equals negative 2. And so I'm going to go ahead and put that on the graph right here. And so you can already see those 2 points kind of box it in on the upper right corner. And so I'll go ahead and draw my graph. Let's see, we'll do it in blue. So here we go. I come down, go through those 2 points, and then just use the asymptotes as guardrails. And there we go. And then the other one's most likely going to be diagonal down here, but once again, you don't want to assume. We need to plug something in. So I could plug in like negative 2 or negative 3. It doesn't really matter. So I'll probably plug in a couple just so we can get that practice again on how to plug values in. So let's start with f of negative 2. So let's see, we'll get negative 2 times negative 2 plus 3 all over negative 2 plus 1. Then let's see, that becomes positive 4 plus 3 over a negative 1. And so we end up with 7 over negative 1, which is negative 7. So when x is negative 2, y is negative 7 down here. Okay, let's see. Let's try one more. Let's try f of, let's see, oops, f of, I don't know, let's see, how about negative, let's get a little more creative, negative 6. Okay, and so let's see, we're going to have negative 2 times negative 6 plus 3, and then all over negative 6 plus 1. Scroll down a bit. And so let's see, when you multiply on top, let's see, that'll become 12 plus 3 over negative 5. So we end up getting 15 over negative 5, which is a negative 3 when we reduce it. So make sure we reduce it. They won't always reduce so nicely. You might have a fraction and it does reduce, but it will still be a fraction. So just be aware of that. So let's see, negative 6, we're down 1, 2, 3 right here. Okay, so I have those points right there. The main thing is when we draw this, just draw it with a curve as I curve up like this and go through the other one, and then just use the guardrail. And there you go, that's it. So just be careful. Like I said, they will ask you to plug in evaluate multiple points. And so you just have to be careful with your algebra and you'll be fine. All right, moving on to our next one. Okay, now we're going to run into I'm sorry, we're not at multiple asymptotes yet. That'll be next. Okay, so here we go. So x-intercept, so to find that, we'll set the top equal to 0 and solve. So 3x squared plus 4 equals 0. Subtract by 4. 3x squared equals negative 4. Divide by 3. X squared equals negative 4/3. And when I square root here, I'm square rooting a negative, which gives me an imaginary value. And so in this case, that means we don't have an x-intercept. Okay. Y-intercept, we'll go ahead and let x equal 0. So f of 0. So 3 times 0 squared plus 4 all over 0 squared. See, so that'll go away there, and I'm left with 4 over 0. Well, that's undefined, so that means we don't have a y-intercept either. Interesting. Okay, let's see, vertical asymptote. Let's look at this. So you set the denominator equal to 0 and solve. So x squared equals 0. The square root of 0 plus minus, it doesn't really make a difference, is just going to be 0. So the vertical asymptote is just at x equals 0. If I plug, that's my restricted value. Can't plug in 0, and actually we saw that right above there. You can't plug in 0 for x. That's my restricted value. That's my vertical asymptote. So at least I got one piece of information now. So x equals 0 is basically the line on it's the y-axis right here. So went ahead and put my vertical asymptote there. Horizontal asymptote, you take the ratio of the coefficients if the powers are the same, the highest power, which they are. So that'd be y equals 3 over 1, or we'll just put that as y equals 3. So go ahead and plot that. So at this point, I don't actually have any points yet because I didn't have an x or a y intercept. But we can go ahead and pick some points, though, and start filling this out. Now, what's interesting about this, and if you recognize this, great. If you don't, it's okay. But this is an even function. This is an even function. If you notice, all the exponents are even. So what that means is whether I plug in f of x or if I plug in f of negative x, it's going to be the same. So for example, if I plug in f of -2, that would be the same as plugging in f of +2. It won't make a difference. So if you recognize that, that will make life a little bit easier to where I'm not having to find, lots of points on both sides. If I find one point on the right, I can just go ahead and reflect it over on the other side. So that's what I'm going to do here. So let's try f of 2. So I'm going to have 3 times 2 squared plus 4 all over 2 squared. And then let's see, we're going to end up with 3 times 4 plus 4 all over 4. And then let's see, then we're going to have, 12 plus 4 over 4. And then we get 16 over 4, which reduces down to a 4. So when x is -2 or +2, I get a 4 in return. So let's see, at -2, I'm up here at 4. At +2, I'm up here at 4. All right, let's try 4 now. That will be a good example to kind of see how sometimes it can get a little messy and you just have to be careful simplifying. So just to remember, it's an even function, so f of -4 is the same thing as f of +4. So it doesn't matter if I plug in 4 or -4, I'm going to get the same result. So let me write this down and then I'll scroll so we can see this a little bit better. So let's see, 3 times 4 squared plus 4 all over 4 squared. Okay, give it a little bit more room so we can see it a little better. All right, so let's see. This will be 3 times 16 plus 4 all over 16. Now don't try to cancel out the 16s. You can't do that. We have to finish simplifying the top before we can do any of that. So let's see, 3 times 16 is 48. And then plus 4 all over 16. And then we end up with 52 over 16. Now, it's correct, but it's not simplified, so we have to make sure we simplify this. And so if you can see what it simplifies all at once, great. If not, we can do it in smaller steps. And so sometimes I like to do it in smaller steps. I notice they're both even. So if they're both even, basically we can just cut them in half. We're going to divide by 2. So half of 52 would be 26, and half of 16 would be 8. Well, you know what? They're still even. So I can go ahead and divide by 2 again on both of them. Half of 26 is 13, and half of 8 is 4. And there we go. That's what we're looking at. And so remember, your answers, they are going to want them as fractions. But that is the same thing as 3.25, and that might help as far as the graphing is concerned. And so let's see. At 4, -4, we're at 3.25. So let's see, about right there and right there. And then from here, we'll go ahead and draw that. Let me just go down here in case you need to see this for another moment, but just be careful. Like I said, that's the biggest thing I have emails about is when it comes to plugging in points. Okay, so up here, use the asymptote as guardrails. So this is going to curve and go up. And same thing with the other side. So like I said, sometimes they can be adjacent. Most of the time they're going to be diagonal, but in this particular example, they were adjacent and actually symmetrical right there. All right, few left here. I think we're looking at the ones with multiple vertical asymptotes. So if we look at the first part right here, so x-intercept, basically we're going to set the top equal to 0 and solve. So x plus 3 equals 0, subtract 3, x equals -3. So if you plug in -3 for x, y comes back as a 0. And so that's our x-intercept. Y-intercept, by definition, let x equal 0. So let's see, we're going to have 0 plus 3 over 0 squared plus 3 times 0 minus 4. And anything with the zeros, you can just cross out. And so we're left with 3 over negative 4. And there we go. So the y-intercept is going to be at, let's see, 0 and then 3 over negative 4. So let's see, 0 and then down 3/4 basically. So that would be about right there. Okay, vertical asymptotes, you have to take the denominator and set that equal to 0. So let's see, x squared plus 3x minus 4 equals 0. And this will factor into x plus 4, x minus 1. And so those vertical asymptotes are going to be at negative 4 and positive 1. So x equals negative 4 and x equals negative 1. So we'll go ahead and put that on here. Negative 1's right here. 1, 2, 3, 4. There we go. And then negative 4 right here. Oops. Sorry about that. I'm sure I confused you with the negative 1. My bad. Here we go. Positive 1. Sorry about that. All right. Positive 1. All right. Okay, so now horizontal asymptotes, if you see here, the highest power on top's at 1, the highest power on bottom's at 2, so that defaults to y equals 0. Okay, so in the middle, I already have 2 points. I'm going to need 3 points, but I think I already kind of have an idea of how this is going to look. It's either kind of has a parabola shape to it, or it has more of a cubic shape to it. And I think this is going to be more of a cubic shape where it gets a little flat in the middle and then keeps going down. So I'm pretty sure it's going to look like this. We can do one more point just to make sure, but pretty sure that's what we're looking at here. And it looks like it probably gets a little flat in the middle, and that can happen sometimes on these, but it kind of has that little twist in it right there. And so, all right, I think that'll be good. We'll find an extra point in a minute. Then what we have to do is figure out a point beyond each asymptote, beyond. So beyond to the left, beyond to the right. So we'll start with the left. So I'm going to plug in negative 5. So let's see, we'll do f of negative 5. So let's see, negative 5 plus 3 all over, let's see, negative 5 squared plus 3 over negative 5, and then minus 4. And then let's see, that'll give us negative 2 over positive 25, and then a minus 15, and then a minus 4. And so let's see, that'll give us negative 2 over 25, take away 15 is 10. 10 take away 4 is 6. And then once again, you want to make sure we reduce that, especially on your homework. So negative 1/3. So at negative 5, we're at negative 1/3. And that's good enough to draw this part of the graph now. So it is going to be, it's a pretty tight fit, but you just want to use the asymptotes as your guardrails, curve going down, curve going up, but flattening with the asymptote right there. And there's the left side of the graph. See, that was part of my asymptote. Okay, so now we got to try something on the right side. So we could try, I don't know, 2 or 3, whatever you want to try. Let's go ahead and try, let's just keep the number small. Let's try 2. So f of 2, so let's see, 2 plus 3 over 2 to the power of 2 plus 3 times 2, take away 4. And let's see, so on top, we're going to get a 5. And then on bottom, we're going to get a 4 plus 6, take away 4. Okay, and so let's see, we'll get a 5 over 4 plus 6 is 10, take away 4 is 6. All right, so let's see, that's going to be not quite to 1, about right there. And once again, that's fine. That's good enough to get a sketch of this. So just use your guardrails. And there we go. There's that picture. Okay, I'll find one extra point just to kind of show you what happens with the middle part. We could do -1 just to get some practice with one more point. So I'm going to plug in -1. So f of -1 would be -1 plus 3 over -1 squared plus 3 times -1, and then that minus 4 right there. On top, let's see, that'll be a 2. And then on bottom, -1 squared actually becomes positive. Then this will become a minus 3. 3 times -1, and then we have to take away 4. And so if we simplify all this, it looks like we're going to get 2 over, see, 1 take away 3 is -2. -2 take away 4 is -6. And then this reduces to -1/3. That's weird because we got that earlier for -5. But all right, so at -1, we're at -1/3, which is actually a little bit higher up than how I drew this. So this really gets flat, I guess, and then curves at the end right there. But you know, your homework, you'll be picking graphs, so they're not gonna have graphs with such small discrepancies. You'll know which one's the right one. All right, our last one here. And so kind of similar to the one we just did. So let's see, x-intercepts. We set the top equal to 0 and solve. So we get x squared equals -4, and we're running into that problem again where I'm trying to square root a negative number. So we're not going to have any x-intercepts on this particular graph. And then the y-intercept will evaluate the function at 0. So 0 squared plus 4 over 0 squared minus 4. And so the 0 squares will go away. We'll be left with 4 over -4, which is -1. And so let's see, that's going to be at 0, -1. Okay, so we have 1 point to work with. Okay, vertical asymptotes, we're going to have 2 of them. So we take the denominator, set that equal to 0, and solve. And so this is the difference of 2 squares. And so we get vertical asymptotes at -2 and at +2. So x equals -2 and x equals +2. So let's see. All right, so there we go. We got those. And we have a point in the middle. Okay. Let's see, horizontal asymptote. Don't want to forget about that. So if you notice, they do have common exponents there. And so you take the ratio. So it's going to be 1 over 1. Those are the coefficients in front, which is just 1. So y equals 1. So we'll have that right here. Okay, so now it's a matter of finding some points to help us here. Now, once again, this is a good thing. It is an even function. So once again, whether I plug in 3 or -3, I get the same result. So f of -3 is going to be the same as f of +3. And so that'll just cut down on how many times I have to plug stuff in to kind of get an accurate picture of this. So let's go ahead and start with that. So let's see, 3 squared plus 4 over 3 squared minus 4. And so we end up getting 9 plus 4 over 9 take away 4. So 9 plus 4 is 13. 9 take away 4 is 5. And you want to leave it as a fraction. Now, as a decimal, that is 2.6, just to kind of give you an idea so we know where to plot this. So let's see, at -3, we're up 2.6. And at +3, we're also up 2.6. And that's good enough to draw this on the outer edges. So that's going to go up with the asymptote and curve down here. And then same thing here. Kind of curve. Oh, there we go. Okay, so we've got the beyond part, beyond the asymptotes. Now in the middle, I only have 1 point. But what's nice is -1 and +1, since it's an even function, they're going to be the same. So I'm definitely dealing with a parabola shape. But I want to go ahead and plug in 1 so I can make sure I get a nice accurate picture. So just remember, -1 and f of +1 will give me the same result. So let's see, 1 squared plus 4 over 1 squared minus 4. So 1 plus 4, 1 minus 4. So we end up with 5 over -3, which is a good answer. Just go ahead and leave it like that. As a decimal, it would be -1.66 repeating. So let's see, we're going to be right about here and here or so, somewhere about like that. And then it's not a parabola, but it kind of has that shape to it. Right there. The difference with parabolas are they don't have asymptotes. They expand out indefinitely. But these, it's going to be within the guardrails. But it has that bowl shape to it. Okay. All right. So I hope this helps. And if you got any questions, feel free to email me.